In this video, I'm going to talk about the natural logarithm. This is a special kind of logarithm, like the common logarithm. The natural logarithm is the base e logarithm. It's a logarithm of base e. So like this, log base e. Do you remember what e is? E is a number, and it's very long. There are a lot of digits. People normally round it to 2.72, but the digits keep on going. So it's like pi in that way, right? Both pi and e have infinite digits. But yeah, people normally round them, right? So pi is normally rounded to 3.14, right? E is normally rounded to 2.72. Yeah, so the natural logarithm is a logarithm with e in the base. So it's a logarithm that basically has 2.72 in the base. Now, you're probably thinking that's a really random number to have in the base of a logarithm, but it's actually really, really important. This is a really, really useful logarithm. Calculus uses natural logarithms a lot. And the natural logarithm is just generally useful whenever you're talking about continuous growth or continuous decay. So, for example, if you have money in the bank and it's growing because of interest, and if it's compounded continuously, then that's an example of where the natural logarithm would be really important. Really important. Uh, uh, what if you have like uranium? Totally different scenario. What if you have uranium or something radioactive and it's decaying, right? That's another that's another scenario where the natural logarithm would be really important. So yeah, natural logarithm is very useful. There are many applications of it. Okay, let's do an example. Let's do an example of a natural logarithm. Let's say we have the natural logarithm of 7.38906, and the digits just keep going on. Okay, so you're probably wondering, where does this number even come from? It's a very specific number. So turns out that is what you get when you do e times e, right? If you do e times itself, or I could have written this as uh, e squared, right? If you do e squared, you will get this long number. So that's where the number comes from. Okay, so let's try to do this logarithm. If you remember, there are two ways that you can think about logarithms. Here's the first way. How many e's do I have to multiply to get this? How many e's do I have to multiply to get 7.38906 dot 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 dot? Well, didn't we just say that 7.38906 was literally e, that's supposed to be an e, was literally e times e, right? This is e times e. Okay, so how many times do we have to multiply e to get the number? Two times. So the answer is two. Okay, that wasn't too bad. Here's the second way of thinking about it. E to what power is 7.38906? E to what power is 7.38906? Well, didn't we just say e squared is the long number, right? We literally just said that. So okay, what power do we have to raise e to get the number? Two, the power of two. So the answer would be two. So yeah, those are the two ways of thinking about logarithms. Okay, so one thing I should mention, of course, since this is e squared, I could have written this logarithm as the natural logarithm of e squared, right? I could have, or, log base e of e squared, right? I could have written it like this. And if I wrote it like this, the answer would be 2, right? Same exact logarithm, just written in a different way, right? Okay. Oh, okay. One more thing. One more thing. There's actually a shortcut for writing this logarithm, right? There's like a simpler way, right? Because people were like, we're writing this logarithm so much. Let's come up with a simpler way of writing it. So this is the way they came up with ln, right? So if I was writing this, I could write it like ln 7.38906 dot dot dot, right? So yeah, ln, that stands for natural logarithm, right? That's like an abbreviation for natural logarithm. Now, you might be thinking, wait a minute, an abbreviation for natural logarithm, shouldn't that be NL? Why is it LN? They switched the letters, right? Uh, yeah, I don't know why it's LN. Maybe that's the abbreviation in like Latin or French, or I it doesn't really matter, right? It's just that this is the abbreviation that a bunch of super smart math people started using a long time ago, and then everyone went along with it, and now we all need to know what it means because it's so commonly used. Yeah, so if you see ln of something, that means the natural logarithm. That means log base e. So this would be equal to 2, right? Because it's literally the same thing as that. It's the same thing. Or we could write it, of course, as ln of e squared, right? E squared, and this would also be 2, right? So these are literally 4 different ways of writing the same thing, right? These are all like the same exact idea. Yeah, so ln is just like a shortcut, a super quick way of writing the natural logarithm, of writing the base e logarithm. Thanks for watching.